Everyone's talking about ChatGPT, Gemini, Claude. But while models dominate headlines, a silent shift is underway that's even more important for AI's future. It's called MCP, a protocol, not a product. And it's quickly becoming the backbone of how AI agents interact with tools, data, and each other. Since its release by Anthropic in late 2024, companies like OpenAI, AWS, MongoDB, PayPal, and even Google are moving fast to integrate it. In the next few minutes, you'll learn what MCP is, why tech giants are adopting it, and what this means for the next phase of AI deployment. The real problem with AI today. Before MCP, there wasn't a standard way for AI agents to work across different tools, environments, or even models. Everything was fragmented. Imagine building a smart assistant using OpenAI's GPT, then trying to integrate it with a database powered by MongoDB or a web app hosted on AWS. You'd typically rely on APIs, application programming interfaces, to make these connections. And while APIs have been the backbone of software integration for decades, they weren't designed with AI agents in mind. APIs are static. They require precise instructions. They don't offer flexibility, and they don't have any sense of identity or context. More importantly, they weren't built for systems that need to adapt on the fly, something large language models are increasingly capable of. So here's the core issue. The AI world has evolved faster than the infrastructure supporting it. We now have agents that can reason, plan, and execute. But they're operating in silos. There's no native way for them to cooperate, share context, or access enterprise tools securely without custom code. This is the gap MCP is trying to close. So, what exactly is MCP? MCP stands for Model Context Protocol, and it was quietly released by Anthropic in November 2024. It isn't an AI model or a product you can buy. It's a protocol, a set of technical standards that allows different AI agents to interact with tools, data, and even other agents across platforms. In practical terms, MCP lets a company expose its internal tools and services to external AI agents securely, selectively, and contextually. And unlike an API that just returns raw data, an MCP server can define fine-trained rules for access, identity verification, and permission scope. Here's how it works. An organization sets up an MCP server. This server wraps around any data source, application, or service they want to expose to AI agents. Then, when an agent makes a request, the MCP server can ask, "Who are you? What are you trying to do? And do you have permission to do that?" It responds accordingly, granting access, rejecting it, or offering limited functionality based on those rules. This allows enterprises to maintain control while opening up interoperability. And that's the key word here, interoperability. MCP is designed to work across different models, different frameworks, and different architectures. It's one of the first steps toward making agent-based systems modular, secure, and scalable. Why MCP adoption signals? A structural shift in AIM MCP is gaining attention not just for its technical design, but because it's already being put to work by some of the most prominent names in tech. MongoDB is using MCP to let AI agents access structured data with precise rule-based control without the need to rewrite or version APIs. This allows developers to manage permissions centrally and update access logic without touching application code. Their product director, Ben Fell, has emphasized the flexibility this provides for enterprise environments. Wix has integrated MCP to enable developers to interact with tools like Claude and Cursor directly within their IDs or chat interfaces. According to CTO Jan Venheim, this aligns with a broader shift toward LLM-powered development, where interfaces are dynamic, intelligent, and context-aware. Speakeasy, a company focused on developer tooling, has taken a similar stance. CEO Sagar Bachu describes MCP as a way to make traditional APIs chat-native, giving agents more natural, flexible ways to access services, reducing manual integration work in the process. Other major players like AWS, PayPal, Cloudflare, and Glean have begun implementing or experimenting with MCP servers. Even companies still in the testing phase, like rocket companies, have confirmed internal deployments as they prepare for a future where agent interoperability becomes standard. This wave of adoption reflects more than early experimentation. MCP is being operationalized. It's not replacing APIs but augmenting them, adding identity checks, contextual awareness, and access controls that APIs weren't built to handle. Because it's protocol-based and vendor-neutral, MCP also avoids lock-in, making it compatible across platforms. Even tech giants that typically compete, Microsoft and Google, have publicly supported MCP alongside their own protocol efforts like Agent 2, Agent A2A, and AGNTCY. This suggests broad industry alignment around the need for open agent-compatible standards. The move from isolated model performance to interoperable agent ecosystems is underway, and MCP is quickly becoming one of the core enablers of that shift. MCP versus APIs. A side-by-side comparison. APIs have been the standard for system integration for decades. They let software applications exchange data through predefined endpoints. But while APIs work well for structured, predictable tasks like retrieving a product price or submitting a form, they weren't designed with autonomous AI agents in mind. APIs are static by nature. They follow rigid schemas, require precise inputs, and return fixed outputs. There's no native way to adapt to context, evaluate intent, or ask who's making this request. This creates friction when AI agents, which operate with dynamic goals and changing conditions, try to interact with traditional systems. MCP, or Model Context Protocol, offers a different approach. Instead of treating access as a one-time request, it functions like a context-aware gateway. It allows agents to interact through a conversational format where identity, permissions, task context, and environment can all be factored into the response. For example, an agent might ask to access financial records, but whether it's allowed depends on who the agent is, what it's trying to do, and what current system state it's operating within. MCP can handle all of that dynamically, whereas an API would simply allow or deny access based on a static rule. Developers can configure these rules at the MCP server level, removing the need for constant API updates or deployments. Instead of hard-coding every possible rule into the backend, teams define access logic once centrally and update it as needed without touching the application code itself. This shift significantly reduces engineering overhead and shortens iteration cycles. This is why companies like Speakeasy, which build developer infrastructure, are leaning into MCP. CEO Segar Bachu says MCP allows them to turn traditional endpoints into chat-native interfaces, meaning agents can ask for what they need in natural contextual ways and receive tailored access and response. It's a more natural fit for AI systems that think in terms of goals rather than endpoints. Importantly, MCP isn't replacing APIs. The API layer still handles the actual data retrieval or service execution. What MCP does is wrap that layer with a policy-driven, context-sensitive interface, giving AI agents the flexibility they need while letting enterprises retain full control over what's exposed and when. In short, APIs were built for predictable software. MCP is being built for intelligent agents, and together they may define the next evolution of system interaction. Competing protocols and why MCP is leading. While MCP is gaining ground, it's not the only protocol in development. Google has introduced Agent 2 Agent A2A, focused on enabling direct communication between AI agents. Cisco, in collaboration with other firms, launched AGNTCY for similar goals. Independent groups like LKA are also exploring their own solutions. MCP stands out due to early adoption and its focus on enterprise needs. Its design prioritizes identity, access control, and interoperability, key for industries handling sensitive data. The protocol's momentum is also a factor. With real-world deployments from companies like MongoDB, Wix, and AWS, MCP is already in motion. In systems like these, early adoption often leads to standardization. However, these protocols may not compete directly. As SAP's Walter Sun noted, agent interoperability may require multiple layers, some for messaging, others for tool access or orchestration. MCP could coexist with A2A or AGNTCY depending on application needs. So, while MCP may not be the only solution, it's currently leading the way in actual usage and support. What MCP unlocks for the future of AI? As AI moves beyond single model outputs and into multi-agent systems, the ability for those agents to coordinate, delegate, and act autonomously across platforms becomes essential. MCP is emerging as one of the protocols enabling that shift, not just for tool access, but for orchestrating intelligent behavior across distributed systems. In future enterprise settings, agents may be responsible for handling tasks end-to-end, drafting documents, pulling internal data, executing code, and validating outcomes, often across tools built by different vendors. Without a protocol like MCP to manage identity, permissions, and context between these systems, that kind of automation would remain fragmented or limited to siloed environments. The protocol's vendor-agnostic structure also makes it flexible enough to be layered into future AI workflows, whether those workflows are built on open-source models, closed APIs, or custom in-house tools. This is particularly important as organizations start composing agent stacks rather than building monolithic systems. As more companies adopt LLMs for internal automation, developer support, and decision assistance, the demand for interoperable, secure, and adaptable infrastructure will increase. MCP offers one answer to that challenge, not by replacing existing tools, but by making them more accessible to AI agents in ways that are controlled, measurable, and scalable. Where HTTP standardized the web for human browsers, MCP may help standardize the AI layer for autonomous agents. And as real-world implementations increase, it's likely to influence not just how agents work, but how digital systems are designed around them. If you've made it this far, let us know what you think in the comments section below. For more interesting topics, make sure you watch the recommended video that you see on the screen right now.